Probability of having a boy would be what? 50%. Girls, 50%. So the decimal we'd use in this problem is 0.5, right? Okay. If we have 0 kids, we can't talk about the problem at all. If I have 1 kid, how are you going to figure out the probability? 50% for the boy, 50% for the girl, right? When we have 2 kids, what's it going to look like? I could have a boy and a girl, which would be the same as girl and boy, right? So how many different families go? Well, we could do it like that. Or we could do that. So what's the probability of having 2 boys? 5%. It'd be 0.5 squared. What's 0.5 squared? 0.25. What's for the girl? Also 0.5 squared would be 0.25. So you can see the probabilities right there. The boy and the girl, or the girl and the boy would be, what's 0.5 times 0.5? And girl times boy? Also 0.25, so when you add those up you have 0.5. So in a situation where there are only 2 kids in the family, those are all the different possibilities. Right? Now we have 3 in the family, so it would be, you could have 3 boys, you could have 3 girls. What else could we have? So it could go 2 boys and 1 girl, or it could go 1 boy and 2 girls. Anything else? Should be it, right? Okay, so what's the probability of having all 3 of 1? 4.5%, but the probability 0.125, right? So with the boys, what's 0.5 squared? Do 0.5 squared times 0.25. You got it? You can just type it in a calculator. You go 0.25. Oops, sorry. You go 0.5 for the boy, and we're saying we have 2 of them, times the 0.5 of the 1 girl. And what did I do? What? Oh, I'm sorry. We got to do one more thing. So with this, how many different ways can you have that? So there are some other numbers that are hidden in this problem. We're actually going to have a 1 here, a 3 here, a 3 here, and a 1 there. Now you might be wondering where that's coming from, and that's what we call Pascal's triangle. So if you look at your notes today, there is a section where we're going to put Pascal's triangle in there. So when you look at it, if I take that 0.125 that we had over here, 3 is 0.375 or 37.5%. So that's the same thing over here, 375.375. So now with that one, can anybody tell me the probability of having 2 boys, 2 girls in a family of 4? Yes. Well, what's the probability, or what's the pattern going to be? I could have all 4 boys, or I could have 3 boys, 1 girl, right? I could have 2 of each. We could have 1 boy, 3 girls, or all 4 girls. So we're asking for that middle one. Does anybody know the hidden numbers? Anybody work with Pascal's triangle? What's that? There'll be a 1 there and a 1 there. 4, 6, 4. So what's the probability? Take 0.5 squared times 0.5 squared times 6. What do you get?
379.
Is it? I don't know. 6 times 0.5 squared times 0.5 squared. So you can take this type of information back into your science class. I know you guys in biology 10 are working, you do Punnett squares. And it's kind of nice. I know the problem we ran into on the MCA asked a question like, what's the probability of having a family of 4, I believe it was a family of 4, maybe a family of 5, doesn't really matter, with at least 2 boys. It was on a practice, not on the actual MCA, but on a practice one you guys might have done. Juniors anyway. So what would you put a circle around? Do any of these families have at least 2 boys in them? Which ones?
All the ones up from the middle left.
So you might circle these, right? So you would take this probability, add it to this probability, and then add it with this one, and it would tell you how many families could have at least 2 boys in them when you have 4 kids. Got it?